Hey everyone, my name's Eric, and today I'll be speaking on the frequency response of LTI systems. As you may know, LTI systems can be described generally in this form you see here, where x of n is our input signal, which is convoluted with our unit impulse response h of n to obtain our output signal y of n. Now, how does frequency response play into this? To show this, let's work our way into the frequency domain by applying the DTFT to x of n and y of n to obtain their frequency counterparts shown here. Now you may ask yourself, what if we apply the DTFT to h of n as well? Well, if you did that, then you'd actually obtain the frequency response h of e to the j omega, which as we can see here is the DTFT of h of n. Now, why is the frequency response relevant? Let's go back to x and y of e of j to omega and call upon the relationship between multiplication and convolution across domains. Recall that convolution in the time domain corresponds to multiplication in the frequency domain. So y of n equals x of n convoluted with h of n translates to y of e to the j omega equals x of e to the j omega times h of e to the j omega. From this, we can see that another way to describe frequency response is actually as y of e to the j omega divided by x of e to the j omega. Now let's explore this relationship with an example. Say we obtained a frequency response h of e to the j omega by applying the DTFT to an impulse response. Say we had a desirable frequency domain output y of e to the j omega. How would we determine the nature of the input signal needed? By taking advantage of the relationship we discovered a few seconds ago and dividing the output by the frequency response shown here. After some quick math, we determine the signal for the frequency domain input and reach our answer. This concludes the video. Thanks for watching.